All right, guys, so looking at the problems we have here, the skill that we're working on in this video is simplifying radicals. And again, hopefully this is a refresh for you. This is something we worked on before break in class, so hopefully this is just to refresh your brain here. But let's go ahead and get going at these problems here. So the first one we're going to look at is this one right here, and we want to go ahead and break this down. Now, as a reminder, our index here tells us our group size. Okay, so when we're looking at our index on the outside, that little number on the outside of our radical, that's what's going to tell us when we split our trees up what size groups we are looking for. Okay, and maybe make a little note at the top of your paper here, groups go outside. Okay. All right, so let's go ahead and make our trees here. Now take a notice, I did this one on purpose because you're going to see this in your practice. We're dealing with a negative. Whenever you have a negative number, what I want you guys to do right away is to pull out a -1. Okay, so then what that's doing is completely taking away that negative, so we can just look at all of our positive numbers from here. So whenever you're dealing with a negative, go ahead and pull that out first, so then we can make our trees from our positive number. So what multiplies to get me 27? I can do 3 times 9. Remember to cross off your numbers. 3 is a prime number. We can't go any further there, but 9, I can split that up into 3 and 3. Okay. X to the 4th means I have 4 x's, and y to the 7th means I have 7 y's. 1, 2, 3, 4, 5, 6, 7. Okay. All right, we've got everything broken down as far as what we can go, right? And now we want to go ahead and pay attention to our index and look for groups of 3. So looking at this right here, I have 3 3s, I have 3 x's, and I have 2 sets of y's that I can make groups from. Now remember, our groups go outside. So remember, we use these and we take them and we fold them all together like what we do with our pair of socks, right? We take this whole group, we put it together, and then that whole group goes outside with us. So this group of 3s is going to go on the outside with us. My group of x's is going to go on the outside with us. And then both of these y's go on the outside with us. Okay. Now taking a look back at our trees, we want to look at anything that's left over, and we've got this -1 right here. Now, when we are dealing with cube roots or any odd root, and whenever we have a negative, we can bring that negative outside. If we're dealing with an even root, okay, so an even number index, that negative is going to go back underneath the radical. The reason is when we have a negative number multiplied twice, right, so an even amount, that automatically gets me a positive. But when I take a negative number and I multiply it an odd number of times, that will get me back to a negative number. So it's okay to have negative numbers come outside when we're dealing with an odd root, an odd number root. Okay, if it's an even number root, that -1 would go back underneath the radical. All right, take a look at our leftover pieces. We have an x and a y left over, so the cube root of xy is going to be left over. So when we simplify this, we have -3xy squared cube root of xy. All right, go ahead and try this next one on your own. So go ahead and pause the video. Make your trees. Here we are looking for, we've got a square root. So go ahead and find your groups of 2, right? Square root groups of 2 here. Go ahead, pause the video, try this one on your own. All right, if you are to this point and you got stuck, we've got all this stuff on the outside. We've got 5x squared y on the outside, and we're bringing more stuff with us on the outside. We're going to bring another 2 on the outside, another 3 on the outside, another x, and then 2 y's are going to go on the outside with us. Okay, and remember, whenever we bring stuff outside, we always combine it all with multiplication. Taking a look back at our problem, all we have left over is the square root of 3xy. So that's going to go back underneath the radical. When we simplify this completely here, I can go ahead and multiply. 5 times 2 would get me 10, times 3 would get me 30. X squared times x will get me x to the third, and I have y to the third here, square root of 3xy. So this would be my final answer. All right, guys, this is simplifying radicals. Remember, groups go on the outside. If you ever have more than one stuff that you're putting together, we always combine it back together using multiplication. All right, guys, use these notes to help you solve the problems on Delta Math.